Okay. I've lost my page already. It's not good. How are you all? So this is quick, just a revision, quick read through of the chapter. So carbohydrates are one of the macronutrients. They're the big ones. We need them in large amounts, and they provide an essential source of energy. They are mainly found in plants, where they are manufactured by photosynthesis. And the only food really that comes from animals that carbs would be found in would be milk. There's lactose in it, which is a sugar. So how is carbohydrates made, or how are carbohydrates made? It's made by a process called photosynthesis, and it's the process by which green plants, using sunlight, make sugar from carbon dioxide and water. Okay, so you might be asked to explain this. Short question, perhaps, or part of a long, not really part of a long question for higher level, I wouldn't say. So what happens is the sun hits the leaves, and the leaves take in carbon dioxide from the air. And down here in the soil, the roots are taking in water, or H2O. Okay. And the chlorophyll which is the green, that causes the green in plants, it takes in the sunlight. Okay, so there's three things happening. Carbon dioxide is being absorbed, water is being absorbed by the roots, and chlorophyll is taking in the sunlight. Okay, what happens then is glucose, C6H12O6, is formed. Okay, and then the leaves release oxygen. So that's why they're so good for our environment. They're so good for us in the home. We should always have plants to release oxygen in the home because it is good for us. And of course, then carbs are produced, which we can eat. Okay, so three things: the carbon dioxide is taken in, chlorophyll absorbs UV light, and water absorbs roots. And what happens is then carbohydrates are formed, your glucose, your basic sugars, C6H12O6, and oxygen, or O2, is released into the air. So there is a chemical equation for this. You might be asked to fill this out, fill in the gaps in a short question. So 6 molecules of carbon dioxide, 6 CO2, plus 6 molecules of water, 6 H2O, where light energy works with chlorophyll, okay, or absorbed by chlorophyll. And what you end up with is C6H12O6, which is glucose, or a basic simple sugar unit, and you end up with 6 O2 molecules, or oxygen molecules, as well. And for every equation means equal, there has to be the same amount of carbons, oxygens, hydrogens this side as there are that side. Okay, so 6 carbons here. So there's 6 carbons here. 6 O2s, 2 6s are 12, plus another O is 13. No, that's wrong. Yes, sorry. 6 O2s is obviously I'm on my holidays. 6 O2s are 12, and 6 O's here is 18. Sorry, 6 H2O. And then you have 6 O's here and 12 here, which is 18 as well. Apologies for that. And then hydrogen, 6 H2 is 12, and you have your H12 there. So it's a balanced equation. Okay. And as we can see from there, in our glucose, the element composition, you have carbon, you have hydrogen, and you have oxygen in your are the three elements in carbohydrate. Okay. Now this might come up in question, classification. So you're asked to put the carbohydrates into groups. Now in junior cert we would have said sugars, starches, and fiber, but because it's higher level home economics, we are taking it up and we are calling them monosaccharides, which are the basic simple sugar units. We are calling them disaccharides, which are 2 sugar units, and polysaccharides, which mean many units put together. Okay, so don't get mixed up, and learn how to spell these as well, or get the gist of them, that the person correcting knows what you are talking about. Okay, so carbohydrates are classified into 3 main groups: monosaccharides, which means 1, disaccharides meaning 2, and poly meaning many. So monosaccharide is a simple sugar. It contains 1 single sugar unit and is the smallest unit of a carbohydrate. So its chemical formula is just like we did there with photosynthesis, C6H12O6. And there are 3 examples you can give for monosaccharide. This might come up in a short question. So glucose is found in fruit, fructose is found in fruit and in honey, and galactose is found in digested milk. So after your tummy has digested the milk, it ends up as being galactose. Okay, and all of these are arranged differently, but they have 6 carbons, 12 hydrogens, and 6 oxygens in each. Now, for higher level, I'm afraid you might be asked, this is the glucose ring, it's called. Okay, but if you look, these 4 here, it's a carbon chain, the carbon ring. okay? And on these four at the bottom, you have an OH and a H at the top. H at the top, OH. H, OH, H, OH. So these four are the same. You can try to picture it like that. You've got an oxygen by itself. And then this is similar. It has a H and a carbon. But instead of just an OH up here, it has a CH2OH attached. Okay, so CH2OH instead. So I'm afraid you would have to have a familiarity with that, especially for higher level. Okay, so the monosaccharide, one sugar unit, C6H12O6, and our three examples are glucose, fructose, and galactose. Sorry. The disaccharides are next. And these are where two monosaccharides chemically combined with the loss of water, H2O. Okay, so and that's called a condensation reaction. So two monosaccharides join, H2O is taken out, and that's called a condensation reaction. So if you look here, C12, H22O11. Now, if we add this together, two of these should be C12, H24, because 12 and 12 is 24, and O6 and 6 should be O12. Okay, so that's what we should be looking for, we think, down here. But you take out the H2, so 24 minus 2 is 22. That's where we get that from. You've taken H2 out. And then O, you've taken one molecule, you've taken one oxygen out as well. So instead of saying 6 and 6 is 12 here, you've taken an oxygen out for the H2O, and that's why it's 11. Okay, so you can add two monosaccharides together and then take out your two hydrogen and your two oxygen, and you'll end up with the chemical formula here for a disaccharide. Our examples then, we have maltose, which is made up of 2 units of glucose that have combined. We have sucrose, which is made up of a glucose and a fructose together. And we have lactose, which is milk sugar, and that's made up of glucose and galactose. So maltose is found in barley, which is a cereal. Sucrose is in the table sugar you put in your tea, and lactose then is found in milk. So you might have heard of people being lactose intolerant. They can't digest normal milk because they haven't got the enzymes to break down the lactose into glucose and galactose. Okay, so disaccharides, two come together, water is taken out, it's called a condensation reaction. The chemical formula is C12H22O11 because H2O has come out. Our examples are maltose, sucrose, and lactose. And for a good higher level answer, you will have to know your glucose plus glucose for maltose, glucose plus fructose for sucrose, and your glucose and galactose for lactose. Okay, and your sources as well. That comes up in short questions too. They might ask you for sources of different things. Now, here then, I've never seen this in all my years, this being asked on an exam paper. But that's not to say it wouldn't come up. I think it'd be very mean if they did, but that's only my opinion. So you've got your glucose ring here, and you've got your other monosaccharide here, and then your two combine with the elimination. You take out your H2 and your O, and that H2O is taken out. Okay, and it's the exact same then. You have your O on your own, your oxygen on its own, HCOH, HCOH, four of those. And then up here, you've got your carbon again, your carbon ring. You've got your hydrogen, but up here you have CH2OH. So they're the exact same as we looked at up here, but they're combining two together with the elimination of H2O. Now, finally then, we have polysaccharides. So this means many of these monosaccharides put together, and it's formed when 3 or more monosaccharides join together, and this results in every time they join, water is taken out. Okay, so there is a new condensation reaction. And the chains of polysaccharides can be either straight, so they're all in a row, or they branch off. Okay. Now the chemical formula for this, again, you have to know this. C6, instead of H12O6, they've taken out the H2O molecules. So C6H10, so that's H2 gone. And O5, they've taken out an oxygen for H2O, and that's N times because every single polysaccharide is different. So rather than learn them all off differently, we just say N because it's a variable number. Okay, so that's why that is there. It's not H12O5, O6. They've taken out the H2O. Examples of polysaccharides. Again, this comes up in short questions. They'll ask you for examples. So starch, we know what starch is. It's in rice, pasta, potatoes, bread. Pectin is found in fruit. We've talked about making jam. And we know that pectin has a great setting agent. So it does that. Glycogen is found in meat. We said that fish struggles when they're caught and they use up their glycogen reserves. And glycogen can convert to lactic acid and be used as a preservative in meat. That's why meat is rested before slaughter. Animals are rested before slaughter. And we have glycogen in our livers as an energy reserve. Okay, we often talk about if you were killed out, you were doing a marathon, you felt you had no energy left, and you saw the finishing line and you made the last burst, it would be the glycogen in your liver that had converted back into energy for you. Okay. Again, stop and start me. I'm giving a lot of information here at this stage, but I think I kind of have to at this stage. So you can stop and start me, rewind, etc., and kind of try and make sense, or jot down a question and ask me when we're back in school. Gums, then, they're found in plants and seaweed. You get them in your ice cream, etc. Guar gums. Carrageen is one, Irish with seaweed. And then cellulose, which is dietary fibre, found in the skins of fruit and veg, nuts, etc. as well. Okay. So again, don't worry about the chemical structure. It's just a long chain. They've better things for asking now than you to draw out that. Okay. So they've taken out the H2O here. That's why it's 10 and 5 instead of 12 and 6. N times because everyone is different. So that's a variable. And then our examples here, starch, pectin, glycogen, gums, and cellulose. Okay. Oh, yeah. Okay. So I'm going to check my time. Yeah. Okay. We'll get this started. And so the properties of sugar, it's soluble in hot water. So if you put sugar in your tea, it will dissolve. Okay. A syrup is formed then when you do dissolve a large amount of sugar in a small amount of water. So hence all your fruit and syrup, etc. Culinary application then. So how do we use this in cooking? That's what culinary application means. It's used as a preservative in canned fruit, such as canned peaches. So when food is canned in a high sugar solution, the sugar draws water from the bacterial cells by osmosis. And we've talked about this lately. Without water, the bacteria cannot grow, and therefore the food is preserved. There's too much sugar. That's the first property of sugar. It's soluble, and it's a white crystalline compound. Sweetness then. All sugars are sweet and give an appetizing flavour to food. Some sugars are much sweeter than others, and there is a point scale of sweetness. For example, fructose here has the highest sweetness rating. That's fruit sugar. And honey, it's found in honey as well. And it has a sweetness level of 170%. And lactose then, which is milk sugar, only has a sweetness rating of 15%. So for instance, there's carrot sugar, there's onion sugar, but they would be way down here with the likes of lactose. Like those vegetables are slightly sweet, especially when they're babies, the baby carrots, etc. But you wouldn't say, oh, I'd have a carrot instead of a dairy milk because it's just as sweet. So there is varying levels of sweetness, and people have different tolerances to those. So the 100% is sucrose, which is your table sugar, okay, that you put in your tea, and then glucose is 75. And because of sugar being sweet, we can add it to baking like shortbread or cupcakes. Okay, we make things sweet, adding sugar to your tea as well. Now, the ability to assist aeration. Okay, I think I gave you notes in this in your copy, so you might have a quick look at those as well. On this, I usually do a note on the board when we talk about this. So when sugar is whisked with egg, aeration occurs. The sugar helps to denature the egg protein. Denaturation is to change it irreversibly. Okay, so it's changed irreversibly, so it causes it to unfold that protein, and it traps air bubbles. So as the protein is unfolding, it traps air bubbles because you're creating the air bubbles when you're whisking. Whisking then, because of friction, also creates heat. Think of rubbing your hands together. Okay, you're creating heat, that's friction. So whisking also does that. And because egg albumin has quite a low setting point, the heat generated by whisking begins to set the egg white or the egg albumin. Okay. So this forms a temporary foam. So it'll last for a little while, or it will collapse unless